Okay, let's start by grading this assignment. This was Learning Opportunity 7A.7. It might be better to not pause in this instance and just let me go through the answers real quick. The equation would be the number of miles equals 22.5 times the number of gallons. You might have been better if I used G for number of gallons, but whichever variables you use is fine as long as you understand that the miles driven is equivalent to 22.5 multiplied by the number of gallons used. And then when you substitute 15 gallons into that equation, which I've done here, you get 337.5 miles. Number 2, and you may notice that I haven't been changing the names. I don't have let me not say it that way. Let me just say there are certain systems I have in place when I'm at school that are more difficult to do from home, and with the number of things we're all trying to juggle, I have to abandon some systems, so hopefully that's not too disappointing to people. If she earns $15 for 1 hour of tutoring, $23 for 2 hours, you've got a sequence, an arithmetic sequence. It's going up by 8 every hour. So you would start the rule with 8n, and then realize that if n is 1, 8 times 1 is 8, but I need 15, I need 7 more than that. And the reason, a lot of times when you're getting paid for a job, this is a very common type of linear function, because you get paid a certain amount per hour. That's the $8 per hour. But you get paid a certain amount in addition to that, a certain constant amount just for showing up. Like maybe it takes you some time to drive to the babysitting job, and so you get compensated a certain amount for doing the job, and then on top of that, a certain amount per hour. That's a very common function. And number 3, a website has 175 hits during its first hour of operation, 350 hits during its second hour. It's going up by 175 each time. So the number of hits equals 175 times the number of hours. Or h equals 175n, or whichever variables you used would be fine there. Number 4, I made a little table. This one's a bit harder. She's reading a novel that is 463 pages long. After the first day, so I chose to make my table this way. And there's different ways to do this, so I'll talk about that before we're done here. But after the first day, so after day 1, she had 423 pages left. So she had read 40 pages of the novel. After day 2, she had 383 pages left. After day 3, she had 343 pages left. So I see it's going down by 40 each time. And so if it's negative 40 is a common difference, that's the coefficient of the variable term. It's negative 40n. But then what would you add to that to give you this first term, 423? Well, if n is 1, negative 40 times 1 is negative 40. I need to add 40 just to get to 0, and then I need to add 423 more to get to 423. So 40 and 423 is 463 plus 463. And I think you can see in this equation all of the aspects of the relationship. I mean, she starts with a 463 page book, so there's the constant term. You start with a 463 page novel. If you read 40 pages per day, it stands to reason that you would decrease the number of pages left to read by 40 each day. So there's the variable term. You could also write this as 463 minus 40n. It means the same thing, because we can, of course, we have two terms that are being added together, and so we have the commutative property, so we could express it this way. Adding negative 40n is the same as subtracting 40n. Then once you understand, and there's other ways to write this relation that would be, that would also be correct. So if you feel like you've got an equation that also gives you the correct number of pages each day, and trust yourself and count it as correct, or if you're just not sure, you can email me or ask on the discussion board. When I substitute 8 days into this equation, I get negative 40 multiplied by 8 is negative 320 plus 463 means she has 143 pages left to read after 8 days. So that's the second part of that problem. Today I'm going over the answers and explaining them at the same time because I don't think it's going to take too long and because I think it's necessary. Okay, this one was on the video, and you can ignore this part. I don't know, that was something I wrote to myself based on something else, but this was on the video. So when one guest arrives, she's given away 3 of the party favorites, so she has 50 left. After 2 guests arrive, she has given away now a total of 6 party favorites, so there's 47 left to give away. And once you realize that the common difference is -3, -3n is the variable term, and then you add 53 to that to get the number of party favors after a certain number of guests have arrived. Another way to write this would be 50. She starts with 50 party favors, and you subtract 3 multiplied by the number of guests minus 1. So when one guest arrives, this becomes 0, and you have your 50 party favors minus 0, so you still have 50 after you've given 3 to the first guest. There's different ways of looking at this that could give you an equivalent equation. And so if you feel like in other words, if you started with something else but you think it still works out, you can trust yourself and count it as correct. And if you're not sure, you can ask on the discussion board or email me. Number 5, by arranging bowling pins in their proper order, a triangle is created. Now, this one will require a little picture. So when there's 1 row of bowling pins, there's only 1 pin. When I have 2 rows of bowling pins, then I have 3 total bowling pins. If I have 3 rows of bowling pins, now I have 6 bowling pins. And 4 rows of bowling pins is on the picture here. It's the one you're familiar with. Once they set up all 10 pins, that's 10 pins. And this equation was given to you. The number of rows multiplied by 1 more than the number of rows divided by 2 gives you the total number of bowling pins. So let's just check that with some of the numbers we have. If n is 1, 1 multiplied by 1 more than 1 or 2. 1 multiplied by 2 is 2, divided by 2 is 1. That gives me the number of bowling pins. Let's just go all the way up to 4. 4 multiplied by 4 plus 1 is 5. So 4 multiplied by 5 is 20. And 20 divided by 2 would give us 10 total bowling pins. So that we confirm that this equation works to give you the total number of bowling pins based on the number of rows of bowling pins. And then when this would be a ridiculous, you'd need a pretty wide bowling lane, but it might be fun to have 10 rows of bowling pins. And if you did have 10 rows of bowling pins, you would have 10 multiplied by 1 more than 10, or 10 times 11. Divided by 2 is 110 divided by 2 is 55 pins altogether. 55 pins. So this one historically has been confusing to students. So I guess if I wanted to boil it down and make it more understandable, is that you were given the sequence, but you weren't asked to find the equation. You were provided the equation. And if you're provided the equation and you understand that n is the number of rows, then you can just substitute any number of rows for n in the equation and solve for the number of pins.